Hello and welcome to Maths 10. Okay, so moving through some of this stuff regarding exponents, of course it will be featured in the recap in episode 12. So for now let's do a definition, and we're going to see that a to the minus n is 1 over a to the n. Okay, so yeah, and this is of course with a not being equal to 0. Okay, so this is a way for us to deal with negative exponents. So yeah, so a to the minus 2 is going to be 1 over a squared. So that's how that works. So we could even do 2 to the minus 2. So let's work that out. So it's going to be 1 over 2 squared. It's going to be a quarter. Let's do 2 to the minus 4. And that's going to be 1 over 2 to the 4. Okay, so 2 to the 4 is 16. So we can see anyway, the denominator, in other words, is going to be the square there. And all these, and the range of the negative numbers, we can see that it's going from, close to, yeah, well, in 2 to the minus 1, it'd be 1 over 2 to the 1, which would be a half. So yeah, so from 2 to the minus 1, do 1 to the minus 1. 1 to the minus 1. So the base is 1 to the 1. 1. Okay. So yeah, so it's basically the answer is going to be anywhere between 0 and 1 when we're dealing with negative powers. Also, let's do something like this. If we have minus 2 to the minus 2, how do we work that out? Well, we know it's 1 over a squared. So we simply put the 1 on top. And then we've still got this minus 2 here. And then we can see minus 2 squared is 4. So yeah. Now let's just make a brief note here. This will get into when we're dealing with complex numbers actually. If we've got minus 1 squared, it's 1. If we've got minus 1 to the 3, it's minus 1. And yeah, and I'll just do just a couple more. Minus 1 to the 4 is 1. Minus 1 to the 5 is minus 1. And this pattern keeps on alternating. So basically, we can say that minus 1 to an odd n is going to be minus 1, and minus 1 to an even n is going to be 1. So that's another way of looking at it. Okay. And here we can just briefly put where n is plus minus 2, etc. And they're all in the integers. Okay. So that's cool. So yeah, so any odd powers we could have, you know, minus 1 to 98 is going to be 1, minus 1 to 97 is going to be minus 1. And that's just how that works. So let's do a couple more rules here. And we've got a to the m times a to the n. Okay. So that was what we spoke about in the last episode. We said, didn't we? We said so this basically, something like that anyway. Okay. So the next thing we can do is again to use brackets to delineate this stuff out. Okay, and we can see these powers going like a power tower. This is kind of quite an important concept in computer science. But anyway, for now we're just we'll forget about that arrow for now. I just wanted to draw attention to it for a moment. Let's just write that out again now, think about it. Okay, so yeah, we can just put that in there. So a to the m to the n. Okay, so what might that be? So again, I'll do the reasoning first. So how many times do we have to multiply a to the m? Well, we have to do it n times, don't we? So we've got all these a to the m's. There's one, there's another, and there's loads more. And then once we count up all these factors, because recall that factors are things we multiply together, and terms are things we add together. Okay. So we can say this has got so there's n factors, there's n loads of there's n loads of a to the m. So we can then say this is a to the m times n. Because we've got our loads of a to the m. So then we just need to times it by n. So let's do 2 squared and then have another 2. So what we're saying is this is going to be 4. It's going to be 2 to the 4, so it can be 16, right? So our a to the m is going to be 2 squared times 2 squared. Because they're how many a? And then we've got n of these, haven't we? Because we've got 2. There's 2 factors. So then we'll put down our base here. M times n is 2 times 2. It's 2 to the 4. Okay, which equals 16. Let's try something else. We'll do 3 cubed. And then we'll put, should we put 4 there? Why not? Okay, so let's see if we can work this one out again. Okay, so how many a to the m's do we have? Well, our a to the m here is 3 cubed. We're going to have 4 of those, aren't we? So we're going to have 4 factors, n factors, you could say. Okay, so then to work it out, what do we have to do? Well, it's a to the 3 times 4. So it's 3 to the 12. We've got 4 factors there. Of 3 cubed. So we've got 4 lots. It's interesting, isn't it? Because that's like, yeah. And you can actually see as well that if we add all the m's, we get 12. So that's pretty cool as well. Okay, so the final one I want to do is ab to the n. Okay, so this is going to be ab times ab times ab. As you've probably guessed by now, there's n factors here as well, because we only need to do it n times to get the answer. Okay, so once we do this, we're going to have well, we're going to have n lots of a, and we're also going to have n lots of b. So there's that. So let's just try it here. Say 2 times 3 in there. And then we'll put in 5. So that'll be how we see our a and b. So we've got 2 times 3 here. 2 times 3. 2 times 3. 2 times 3. 2 times 3. Don't know what happened there. We've got n, and we've got 5 factors. N factors. Okay. So how many lots of 2 do we have? Well, we've got 2 times 2 times 2 times 2 times 2. We've got 5 lots of 2. How many lots of 3 do we have? We've got 5 lots of 3 as well. So it's 2 to the 5 times 3 to the 5. And yeah, that's fairly self-explanatory as well. So yeah, I think that's going to do it for now. Yeah, just write this down actually. Distribution, this is very important. I should write it. distributes. Inside factors. Okay, so that's about all I wanted to talk about here. Like I said, there's more rules as well with exponents. I'm going to be focusing on exponents quite a lot because this stuff is so important for algebra that it doesn't necessarily focusing on this isn't necessarily such a bad thing. Focusing on all these rules as well. You know, maybe I'm starting to think maybe I'll put in some a bit more mixing together some of the stuff we did in the earlier sections as well, a bit with the fractions. I'm trying to get a real feel for negative powers, negative fractions, as well as these rules as well. So it's going to be a lot more of this type of stuff, I think, for quite a while. So yeah, so that's the end of this. So thanks for watching.